Hello, for data communications and network one class today, Ajahn Suna will talk about the network topology. Network topology consists of the physical structure of the network and logical structure of the network. The physical structure of the network or the physical topology will include how device, cable, and also other components of the network are connected together. Okay, and it may include the device location, the cable type, the distance between device. Actually, in the mathematical sense, the word topology, okay, in math, okay, just the connection, okay, doesn't care, just how things are connected, okay, it's connected like this or it's connected like this, okay, and this and this. This and this will be the same, okay, this is just like how it connected without the regard to like the distance, okay, but in the actual network topology, in the physical sense, we may like to know also the distance between the device, okay. For the logical topology, okay, this is the way that the data are transmitted inside the network, okay, and how devices are communicated with each other, how the packet data are routed inside the network, okay. Now let's look at the type of the network topology. The first one is point-to-point. The point-to-point link, we have talked about this a lot before we get into the network. Is what I usually draw like this, A to B, okay. So in the all the clips, okay, before the wide area network, they are all point to point, okay, connection. And then we have bus, okay, bus I will explain more in a little bit, okay. We have the common line, okay, one single line, and then we have many devices connected to the same line, okay. Then we have ring. I will also explain a little bit more about ring also. So the ring is just we put it in a circle, okay. So we send packet, okay, along the ring, okay, and it have like connected like this. Okay, so you will look at it in a little bit more detail in a little bit, okay. Then we have star. Star will be in the next clip video. We have like the hub here, and we have like many device. Hub is in the middle, and then we have many device. Every device connected directly to the hub, okay. This star. For the tree is like you have like kind of many bus, connected together and no loop, okay. Tree means that there is no loop, okay. So we have like bus, and then we have like many bus connected together like this, okay. Then we have the mesh. The mesh is the network that connect to everyone. Suppose this is your device, right? So you connect to this, connect to this, connect to this, connect to this. So you connect to every device. So the mesh is like the kind of it connected to everyone, okay. So we have many cabling, okay, but you can send directly to the destination, okay. Then we have the hybrid, okay. The hybrid is that you combine many type of network together, like you have the star, okay, and then you have ring, okay, and then you have bus, and they are connected together. The hybrid, we will see this when we talk about internet, okay, because internet is come from internet working, okay, which means that we have many networks, okay. We can have different protocols, different structure connected together. So this we will see in the internet, okay. And what I will explain more in more detail is these three topologies, okay, as it will be used in some standard of LANs, okay, local area network that I will talk about later on, okay. So I will explain more on this. The other is the mesh is kind of like you have a lot of connections, okay, which is good in some applications that you can go directly to the destination. Okay, now let's look at the bus topology. All devices are connected to a single communication line like this. This is the single communication line, and then you have tab. Okay, so in the old standard, okay, we have coaxial cable that used in LAN, okay, in the old LAN standard, okay, of Ethernet. We have and this is LAN, okay, a type of local area network LAN that we use bus topology, okay, and we use coaxial cable, and we have tab to connect to every device, okay, and then we have a terminating resistance. This is terminating resistance, okay, at both ends, okay. This is terminating resistance that will absorb the signal, because when you send the signal both ways, okay, like if you have a packet going both ways, okay, so at the end this terminating resistance will absorb the packet or the signal, okay, so that it will not reflect back into the bus, okay. So this is suitable for small network, okay, because you know that signal strength will attenuated along the when you have more distance, right? When you send longer, the signal strength is attenuated, so you don't want the cable to be too long. Okay, it's simple and easy to connect or remove the device. This is the strength of the bus topology. If you want to add like this device, one more device, it's simple to do, okay. Or if you want to remove it, okay, you can take it out easily, okay, without affecting other device. A transmission by any station propagate in both directions of the bus, as I show you here. We go both directions, okay. So it's broadcasting. All station can receive it, okay. So you need addressing to indicate the intended receiver. Suppose this is A, you want to send to D. So in here you have to have addressing that destination is D, okay, so that D will read it, but other people will not read it. But suppose this is a bad guy, okay, a hacker, okay, hacker may tap here and then read everything, okay, it will read everything, so it can get your information, right? And to prevent the hacker from being able to read it, okay, we will need encryption to for like the message should be secure, okay. But the encryption topic will not be talked about in this data communication class, as it is will be in the applied coding class. I'm also teaching applied coding, okay, next semester, so you can ask me, okay. So we also have the video for the applied coding if you search my name, okay. So we have another class, applied coding, okay. Now for the bus topology, to continue, okay, this is the same. Terminating resistance prevent the signal from reflecting to the bus, okay, and not for a long distance, as the signal is attenuated with distance, okay. It's half duplex transmission, okay. So if the main transmission line is broken, the entire network is down. It's half duplex because this, okay, if you look at this, okay, suppose this person send out the signal, okay, and then this guy also send out, okay. What happened is that it will collide, okay. So in bus we have like for broadcast network, okay, we have for broadcast network. Okay, we have multi-access problem. Okay, we want only one user to send okay, only one user to send at a time. Okay, to avoid collision. Okay, so if more than one user send at the same time, okay, the information, the data can will collide. Okay, so get cause collision. So you want only one user to send at a time. Okay, so this is like multi-access problem, like because you have many users and it's a broadcasting network. Okay, so you have to overcome the multi-access problem. Okay, the multi-access problem can overcome easily. Okay, using ring topology. Okay, the ring topology, the nodes are arranged in a ring. Okay, it's simple to install. A ring is like this. It's like a circle. Okay, it doesn't have to be actual circle. Okay, it's just that it connect. Suppose maybe like this. This is also a ring. Okay, this is also a ring. Okay, because it just has you know this is also a ring topology. Okay, because it have like two neighbors. So this is your node. Okay, A, and you have neighbor 1, neighbor 2. Everyone has two neighbor. Okay, and you connect into a loop, into a circle. This is a ring. Okay, it's simple to install. Just connect to other two devices and connect all the way. Okay, to get a loop. But if you want to maintenance, maybe if you want to maintain this link, then you have to stop the operation for the whole ring. Okay, for the maintenance. So maybe a little bit more complicated to maintain. Okay, than the bus. Suppose you want to maintain like this node, maintenance this node, you have to make the network stop operating at that time. Okay, now the data can travel to ring in one or both direction. It can go this way, or you can have a bidirectional ring. Okay, and each device has two neighbors exactly. Okay, packet travels along the ring moving to each node. So it will go like packet go to this node and then send out, go to this node and then send out like this. Suppose this is destination. Okay, if the packet arrive here, it will read it. Okay, the destination will read the packet, right? If the destination read and then take the packet out of the network, okay, it's no longer transmitting the packet back, to the source. Okay, so this is called destination removal. So destination read the packet and absorb the packet. Okay, so these packets come out of the network. Another way is you can let the source remove the packet. Okay, so it's called source removal. This is like the source is the one who I'm sending this out, so I'm taking it out of the network. It's my responsibility, something like that. So you have two choices: destination removal or source removal. Okay, disadvantage of ring is that if one node go down, okay, the entire network is down. Okay, but for the multi-access problem is very good, easy to overcome multi-access problem. For the ring topology. Okay, easy to overcome the multi-access problem. Okay, if you want only one station to send at a time, okay, you use one token. You have one token. Okay, as in the token ring protocol of the local area network. Okay, this is an old standard of the local area network, okay, that use ring topology. In this protocol, okay, you have a token. So if you, okay, you have, okay, suppose A has a token. If A has a token, A is the only one who can send, okay? Other people that don't have token cannot send, okay? And that's if you allow, if you have only one token in a network, in a ring network, okay? So no collision. If only one token in the network, no collision, because only one who have like a special permission, which is the token, can send. Other people cannot send. If you finish sending, you pass the token to the other node, okay, and then they can send. Okay, so no collision, okay, you can overcome multi-access problem easily than the other broadcast network, okay. Now normally ring network is half duplex, okay, so data move in one direction at a time. But if you want bidirectional, okay, communication, you can use dual ring, become full duplex ring, okay. So this is the unidirectional ring. Okay, but this is like bidirectional. Okay, because you can send and then send back, okay, two ways, okay. So become bidirectional rings, okay. Cool. So that's it for the bus and the ring topology. And for the next clip, we will talk about star topology, okay, like other topologies, okay. I try to update, the information on this. You can also keep updating, okay. In DataComm, you must keep updating all the time, okay, of what is going on, okay. So thank you very much.